Okay, students. So we'll go through a little bit of theory in electrostatics, and we'll start with what are the properties of charge. And so, what comes to your mind when you look at this? Uh, what are the properties of charge? So let's look at the first point. That is, charge is a scalar quantity. Scalar quantity. Right. So, what do you mean by scalar quantity? And this is very important. That charge is basically a property of an elementary particle, just like mass is a property of an elementary particle. And so charge is only a quantitative substance. It is a quantitative substance with no direction. So unless and until there is a charge, say Q, and it is producing an electric field in a particular direction, for example, this. So this electric field will have a direction. And this electric field will be called as a vector quantity. But charge in itself is a scalar quantity. And so what you mean by scalar quantity is there can be a number of charges. There can be a number of charges in a particular system. And you can find the net charge of the system by simply adding all the charges in the system. So I hope the first point is clear that charge is a scalar quantity. Let's look at the second property now. Let's look at the second property. Okay. All this is given in your NCERT books, so you can read about them. This is very important to know. So you always know what you're talking about. When you say charge, you should know what you're talking about. Let's look at the second one, and that is charge is always associated with mass. Charge is associated with mass. Okay, charge is always associated with mass. Charge cannot exist without mass. Okay, though mass can exist without charge. Okay, so charge cannot exist without mass. There has to be a certain elementary particle having a certain amount of mass, which then will be having a certain amount of charge. Okay, if there is an elementary particle which has no mass, then forget the idea about charge. Okay, this is as simple as it gets, that charge is associated with mass. Without mass, there is no charge. Okay, without mass, there is no charge. Now look at the third property. What does the third property say? Let's look at the third property. Third property is it is transferable. That is, charge is transferable. What do you mean by charge is transferable? Basically, you can transfer charges from one system to another system or one object to another object. Okay, if they are either put in contact with each other, there are three ways to do it. Conduction, induction, friction. So that comes under methods of charging. But charge is transferable. Okay, it can be, an object can be charged, an object can be discharged as well. The process of charging by transfer of electrons is called conduction, charging. Okay, let's look at the next one. Accelerated charge always radiates in the form of electromagnetic waves. Okay, it radiates electromagnetic waves, but at what what I mean is it radiates electromagnetic waves, but on what condition? Condition is it is accelerating, an accelerated charge. Okay, an accelerated charge will always radiate energy in the form of electromagnetic waves. Okay, these are 4 properties. We'll go to the 5th one. Just okay. Now this the 5th one. Okay. 5th property is charge can be detected and measured with the help of a voltmeter, ballistic galvanometer, or a gold leaf electroscope. Okay, charge can be detected and measured. Okay, can be detected, okay, and measured. Can be detected and measured with the help of what? With the help of a voltmeter, with the help of a ballistic galvanometer, or a gold leaf electroscope. And we will see what this voltmeter, what this galvanometer is in current electricity and all. Okay, so you don't need to worry about this. And the last 6th, not the last, the 6th property. Okay, the 6th property is that charge is invariant. Charge is invariant. And this is interesting. Basically, if you take a charge and you accelerate this charge, maybe at some speed, let's say at the speed of light, the thing is the charge never changes. But you will always see that when you accelerate a particular elementary substance, okay, having some mass n, when you accelerate it at the speed of light, then your mass is going to have some changes in it. There will be a difference in the mass. Okay, there will be a difference in the mass. And so what they observed was charge is invariant in LHC, large hadron collider. When you take an electron, when elementary particles have been accelerated at a high speed of light, not exactly at the speed of light, but say somewhat there. It's not yet possible. And so what they have observed is that the charge does not change even when it is accelerated. So you need to remember this property, that if there is a question which comes that charges, maybe there's a charge which has been taken at a certain speed, then what will be the difference of charge from the starting point at t is equal to 0 to t is equal to some time interval. So it will be the same. Okay, so charge is invariant. Charge on our body does not change, whatever be its speed. Okay, now let's look at the 7th property, and that is quantization of charge. Quantization of charge, and I want to explain this part. Quantization of charge. Let's talk about quantization of charge. So now this is the 7th property, and it is called quantization of charge. Basically, what happens is electrons have a charge of 1.6 into 10 raised to minus 19. Okay, 1.6 into 10 raised to minus 19. And what basically happens is every system of charge, okay, every system will only consist of packets of this amount. Every system will only consist, okay, 1.6 into 10 raised to minus 19 coulombs. And so every system of charge will either be an integral multiple of this number, And so you need to know that there is a formula which says Q is equal to N into E. Okay, Q is equal to N into E, okay, which is system of charges will be equal to number of charges present into the charge of an electron. Okay, system of charges equals to number of charges present, number of charges present into the charge of an electron, where E is equal to 1.6 into 10 raised to minus 19 coulombs. Okay, E is equal to 1.6 into 10 raised to minus 19 coulombs. Okay, we'll see a question on this. And let's look at the eighth property, that is conservation of charge. What is the eighth property? Eighth property is conservation. Conservation of charge. Okay, so what do you mean by conservation of charge? Basically, total charge. Okay, in our system, the difference between the positive charges and the negative charges within a system will always be constant or conserved. Will always be constant. Okay, they'll. Let's look at two numericals. Yeah, let's look at it. First numerical is okay. I'll read the question again. A copper sphere has 2 into 10 raised to 22 atoms. The charge on the nucleus of each atom is 29 E. What fraction of the electron must be removed from the sphere to give it a charge of plus 2 microcoulombs? Okay, so I'll remove this entire thing. So the total number of electrons, okay, total number of electrons will be what? The total number of electrons will be the total number of atoms into 29E. Okay, because the charge on each atom, the charge on each nucleus of an atom is 29E. Okay, and so the sphere is already containing 2 into 10 raised to 22 atoms. The sphere already has 2 into 10 raised to 22 atoms. Say this is a sphere, it is having so many atoms, and that is 2 into 10 raised to 22 atoms. And each atom is having a charge on its nucleus which is 29E, E in the sense electrons. So 29E. So total number of electrons will be what? 29 into total number of atoms. 20, that is 2 into 10 raised to 22. 2 into 10 raised to 22. Okay. 2 into 10 raised to 22. So how much is that equal to? How much is that equal to? If you equate it, if you calculate, what you'll get? If you calculate it, you will get around 5.8 into 10 raised to 5.8 into 10 raised to 23. 5.8 into 10 raised to 23 electrons. So now this is the total number of electrons we got. Now the question was, what was the question? It was saying what fraction of electrons must be removed from the sphere to give it a charge of plus 2 microcoulombs. So now see, understand this, that 1 coulomb is equal to 1.6 into 10 raised to minus 19. Okay, so that is one charge, say suppose an electron, and we are taking the magnitude of it, so we're not taking a negative. Okay, electron charge is minus 1.6 into 10 raised to minus 19, but just for calculation purpose we'll take it as positive. Okay, just for calculation purpose. So one electron is 1.6 into 10 raised to minus 19 coulombs. Then what will be, okay, what will be basically 2 microcoulombs? 2 microcoulombs is what? 2 into 10 raised to minus 6 coulombs. So how much will be the number of electrons? So it will be what? 2.6 into 10 raised to minus 6. 2 into 10 raised to minus 6 divided by 1.6 into 10 raised to minus 19. Okay. So what is this we are calculating? This is the amount of electrons that we are removed. Okay. This is the electrons, number of electrons that are to be removed. So how much it will come? It is this number of electrons that are removed. Okay, so I'll write here electrons removed. Electrons removed will be equal to 2 into 10 raised to minus 6 divided by 1.6 into 10 raised to minus 19. Okay, 1.6 into 10 raised to minus 19. And how much you will get with that? How much you will get? You will get 1.25 into 10 raised to 13. You will get equal to 1.25 into 10 raised to 13. This is the number of electrons that are removed. Okay. First, what we got, total number of electrons. How much is that? 5.8 into 10 raised to 23. Okay, 5.8 into 10 raised to 23 is what? The total number of electrons. Okay. Second, what we got, the number of electrons that we removed, or the number of electrons that need to be removed to form 2 into 10 raised to minus 6 coulombs or 2 microcoulombs. Okay, 2 microcoulombs. So we found, it is given in the question that how much, what is the fraction of electrons that must be removed from the sphere to give it a charge of plus 2 microcoulombs. Okay, to give it a, so what we did, we know that one electron has this much coulombs. So 2 microcoulombs, you should know that 2 microcoulombs is basically 2 into 10 raised to minus 6 coulombs. So what we want to know is that 2 into 10 raised to minus 6 coulombs is how many electrons. So what I did, I just 2 into 10 raised to minus 6 coulombs into 1 electron divided by 1.6 into 10 raised to minus 19. And that will be how much? 1.25 into 10 raised to 13. So we have two values. One is total number of electrons and the electrons that are removed, okay, to form 2 microcoulombs. To form 2 microcoulombs. Now, okay, keeping these two in mind, just remove this so you can pause the video, write down the values. And so, okay, so we got total electrons equal to how much? 5.8 into 10 raised to 23. And electrons removed, that will be equal to how, that was how much? 1.25 into 10 raised to 13. So what will be the fraction? What will be the fraction? The question says, what is the fraction of electrons that must be removed from the sphere? So to get the fraction, what we'll do? We'll simply do electrons removed upon total number of electrons. Electrons removed upon total number of electrons, or just see that there is a system of charge. There is a system of charges. Okay. And now what you have found out, total number of electrons in this is 5.8 into 10 raised to 23. That is this one. Okay. And now what you have done, you have found out the total number of electrons that was removed. Total number of electrons that was removed. Okay. Here, suppose here I am taking that this is this, if you remove, you are getting a charge of 2 microcoulombs on this system, plus 2 microcoulombs. Okay, this is the total number of electrons that are removed, 1.25 into 10 raised to 13. If you remove that, it will produce a charge of plus 2 microcoulombs on the system. But what is asked is the fraction. So what is the fraction? So basically, if you take this small amount, if you take this entire amount, this entire total number of electrons, and divide it by this small amount, okay, you divide it by this small amount, basically you are going to get a fraction. You are going to get a fraction. So the fraction is equal to electrons removed. Okay, that is electrons removed upon total number of electrons. Electrons removed upon total number of electrons, 1.25 to 10 raised to 13 upon what? 5.8 into 10 raised to 23. 5.8 into 10 raised to 23. So how much you will get that? How much will be that? That will be 2.16 into 10 raised to minus 11. 2.16 into 10 raised to minus 11. Okay. So this is the fraction. This is the fraction, okay, of electrons that must be removed from the sphere to give it a charge of plus 2 microcoulombs. Okay. Record. So let's look at the next question. Simple it is. It's a very simple question. Okay. What of the following charge can be possible? Options are 1.6 into 10 raised to minus 19 coulomb, 1.6 into 10 raised to minus 18 coulomb, 1.6 into 10 raised to minus 20 coulomb, and none of these. So what is the answer? Basically, what is possible? What do you mean by what is possible? He is asking, I mean, they are asking that can a charge have this many coulombs in it? Or can a charge have this many coulombs in it? Okay. So again, the concept comes from quantization of charge. I told you that quantization is basically, what is the meaning of quantization? That any system of charges will be an integral multiple of what? Will be an integral multiple of 1.6 into 10 raised to minus 19. Okay, so let's look at each of these, you know, let's look at each of these individually. So just rub this. So you will get the first one. Let's look at the first one. First value was 1.6 into 10 raised to minus 19 coulombs. Okay, apply this. Q is equal to N into E. Q is equal to N into E, where Q will be the total number of, okay, total charge, and N is basically what? Number of electrons. Okay, N will be number of electrons into the charge of electron, into the charge of electron. So we know that if suppose we consider this to be the charge of a system, let's put it 1.6 into 10 raised to minus 19, and this is equal to N. Taking E down, you'll get 1.6 into 10 raised to minus 19. So this is equal to 1. So here N is what? N, I told you, N is the integral multiple. That means N belongs to an integer value. N belongs to an integer value. And so N is 1. So therefore, this is possible. Okay, this is possible. Let's look at the second one. Okay, the second one was 1.6 into 10 raised to minus 18. So similarly, in the same fashion, we will solve it. This will be 1.6 into 10 raised to minus 18. Take this E down. That is 1.6 into 10 raised to minus 19. And this will give you what? 1.6 cut 10 raised to minus 18 plus 19, which is what? 10 raised to 1. So 10 raised to 1. So N is equal to 10. So is this the integer? It is an integer. So is it possible for a charge to have this? Yes, it is possible for a charge to have this. Okay. So second option is correct. Let's look at the third one. Third one is 1.6 into 10 raised to minus 20 coulombs. Now, similarly in this fashion, Q is equal to N into E. 1.6 into 10 raised to minus 20 is equal to N. I take E down. It is 1.6 into 10 raised to minus 19. That will be equal to what? What you will get? You get 10 raised to minus 20 plus 19. That is equal to 10 raised to minus 1, which is basically 1 upon 10. And is this an integer? This is not an integer. Okay. This is not an integer. So 1.6 into 10 raised to minus 20 coulombs is not possible. It is not possible. Okay, so what are the methods of charging? What are the methods of charging? So there are three methods. Look at the first method. Okay, the first method of charge, okay, is basically friction. Basically friction. Now, what do you mean by friction? What happens during friction? Suppose you take a simple glass rod. Okay, take a glass rod and rub it around with a silk cloth. Okay, you rub it off against a silk cloth, then what will happen is the glass tends to attain many positive charges, and this cloth has an affinity to absorb negative charges. Okay, it absorbs all the negative charges from this. And so now when you take this, when you take this glass rod, which is now positively charged because it's given electrons. So what is the meaning of being positively charged? Basically, it has more number of protons than it has more number of positive charges, okay, than electrons. That is why we call it as positive charge. Now if you take this rod, okay, against pieces of paper, so let's just consider a big piece of paper. So that, let's just consider a big piece of paper. Okay. What is going to happen now is basically you brought it next to it, you brought this glass rod next to a paper. It is going to attract all the electrons of this paper towards this side. All the electrons are going to come on this side, and all the plus signs will be repelled because of this positive charge on this side. Okay. So this is what happens, and that is why the piece of this, the paper piece will get attracted to the glass rod. Why? Because it is trying to shift all the electrons or all the negative charges towards itself and repel all the positive charges towards itself. That is why there is a force of attraction. That is why there is a force of attraction. Okay. Force of attraction. That is why there is a force of attraction. Okay. So this is simply by the means of friction. So just imagine when you take two objects and rub it off against each other, there is a flow of electrons and protons. But remember that the charges which come on the glass rod and which are transferred to the cloth are basically going to be same amount. They will be the same amount of charges. Okay, it is not that more number of electrons will go here, less number of protons will come here. That is not less number of positive charges will come. It's not like that. Okay, what is going to happen is equal amount of charges are going to get transferred. As many as negative charges are transferred here, that many number of positive charges will be transferred on the glass rod. I hope this is understood. Let's look at the second method of charging. Conduction. So basically, when you bring two conductors, say suppose this is a metal rod, okay, and this is a metal plate, okay, the metal plate, the metal rod, and this has a number of positive charges. Okay, this has a number of positive. This is positively charged rod. Okay, and this is neutral. Let's say this is not charged. This is having the same number of charges. Okay, same number of charges. Both the positive charges and negative charges are equal amount. Okay, so this is not charged, and so, but basically these are two conductors. When you bring it in contact with it, when you bring this in contact with it, let's say it's in contact, what will happen? When you take this rod and you move it and you touch this plate with the rod positive charge, what basically happens is all these positive charges are going to, first of all, since they are all positive, they're going to repel each other. They're all going to repel each other. And so you can see that if they keep repelling each other, okay, this positive charge being touched by an object which is neutral in charge is going to jump here. Okay, it's going to jump here. Okay, and again, what will happen is the repulsion keeps continuing till there is an equal amount of potential in this charge, okay, till or in other words, there is a equal number of charges on the plate, and that should be equal to the number of charges on the rod. both will be both will be the same, both will be the same. So when two conductors they are brought in contact, okay, the flow of charges takes place from one to another, until both are at the same potential. Both we'll understand what is potential. If you don't know what potential is, we'll understand that later on. But just remember that the number of positive charges will transfer to a neutral object, to a neutral conductor, till the forces of charge, or the potential, I'll say, is basically equal to each other. So then what will happen is the force of repulsion will be reduced. The force of repulsion in the glass rod in this metal rod will be reduced. Okay, let's look at the third one. Okay, so the third property of the third method of charging is basically induction, and this is very important. This is a very important method because there are many concepts, many things which run on induction, and you will study as it is there in your syllabus. There are many things in your syllabus which are quite interesting, and so you'll understand how induction can be used to actually run a motor. There are induction motors as well, and it's very nice to see how an induction motor works based on this concept. And this is a very simple concept. What basically happens, this example is even in your NCERT books. So you can see that you have, say, a sphere, and you are bringing a charged object. Okay, you bring a charged object right over here. You're not touching it, you're not rubbing it off with, okay, you're just bringing it close to it. Okay, you're bringing it close to it. And so considering to the fact that this is a neutral object, consider that this is a conductor, but the number of atoms, number of positive charges and negative charges are going to be equal. Okay, they're all equal. There's a positive charge here, there's a positive charge here, positive, negative. They're all equal. But as soon as you bring this over here, what is going to happen is all of the charges within this conductor. Okay, remember, both are conductors. Okay, both of these are conductors. What is going to happen when you bring this rod with this object which is charged close to it will start to attract, okay, all the negative charges, or it will align all the negative charges towards itself, and the positive charges will be repelled. Okay, they will be repelled. Okay, all the negative charges will come here. Okay, so what happens is there is a potential here. There is a potential. This becomes positive, this becomes negative. So if you bring a charged object, say a positively charged object, what next to a conductor which is neutral at present, it will attract number of electrons towards its side, and it will repel all the positive charges towards the other side. So what basically happens is you create a potential. Okay, and this method, you're not transferring charges, but you're inducing them. And that is why the name induction. Okay, you're not transferring charges by rubbing it off or by touching the conductor. What you're basically doing is you're creating a potential, you're creating a difference. Okay, you're creating a difference. You're creating a positive difference with a negative difference, which is basically potential. Okay, you're doing that without touching it. So this is basically called induction, because in other words, you're inducing charges. You're inducing charges to align themselves in a conductor by bringing a charged object close to it at a certain distance. Okay, R. Okay, at a certain distance r. So these are the methods of charging. Three basic methods of charging. One is friction, second is conduction, and third is induction. Okay, all three methods are very important, and it's good in terms of theory.